Beginning of 7th grade, we've been spending some time in a variety of problems of the day and in the function game, looking at how variables can be used to define patterns. The assignment that you have today is a way of combining a lot of what we've looked at so far. Let's say the first diagram in a series looks like this. The second diagram looks like this. The third diagram looks like this. Sorry, I'm not very good. I could look and I could think of this as a function machine where the incoming number is the number of triangles and the outcoming number is the number of dots. So I can see when there is one triangle, actually, I'm going to leave room up here. When there's one triangle, there are 3 dots. When there are 2 triangles, there are 4 dots. When there are 3 triangles, there are 5 dots. So in the sheet that you have to do, the first thing you have to do, are asked to do, is draw the next, I think they ask for 3 figures, could be just 2. So in our example, that would look like 1, 2, 3, 4. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6. Okay, so if I continue this pattern, 4 triangles has 6 dots, 5 triangles have 7 dots, 6 triangles have 8 dots. And I'm sure at this point you've all noticed, you've all noticed that the out number is always it's going up by 1. And if you look at the reason why, if I, for example, looking at this figure 3, if I erase this dot, oh, why isn't it erasing? I don't know why that's erasing. Not erasing. Is it there? Anyway, you can see that the only thing that got added is just this one new dot right here. That's the one that's getting added, because this one moves to the bottom, and then this is the only new one. So that's what it looks like in the figure. It might say then, how many dots in 10 triangles? Okay, so you can just imagine if it's going up, that's 6 plus 4. This one is also going up 4, and that makes sense that it's 12. I'm asking you to also try to think about how many in n triangles. If the rule, if I extend this up, and I say, let's say I'm putting an n, what comes out? Now hopefully you remember from our function game that the most important thing to ask yourself in the figuring out the function rules, what comes out when 0 goes in? And if each of these is going down, right, it's going down 1 every time, it's easy to imagine that when I have 0 triangles in the abstract, that there would be 2 dots. And that means that plus 2 is part of the rule. So I might say, what was 3 before I added that 2? 3 was, before I add 2, 3 was 1, 4 was 2, 5 was 3. So clearly it's just the same as this. It is n plus 2. The other part of this, though, we haven't done. We haven't reviewed how you go from that to a graph. And we said with 0 triangles, there were 2. With 1 triangle, there were 3. 2 triangles, there were 4. 3 triangles, there were 5. The number of dots, these are the dots, and these are the triangles. And I think you can clearly see that the number of dots depends on how many triangles. Okay? In general, we're going to see this a lot in algebra. The in number is like x, and the y number is, and the out number is like y. And these numbers can be transferred right to a graph. If I extended this, I would have the coordinate graph. But for now, these are all positive numbers. So this is the x-axis, this is the y. From now on, the x-axis will always be the independent variable, and y will always be the dependent. Like we said, the dots, that's y, depends on how many triangles, that's x. In any graph, we have to put our numbers in, and they have to be at equal intervals. This has to be equal to this. These are equal intervals when I put in my numbers. So I have 0 triangles. I have 1, 2, 3, and we went all the way up to 6, 5, 6. And I think it makes sense because these are going up by 1. We're just going to label these 1, 2. This has to be 0. The bottom has to be 0. Some kids forget that. 1, 2, 3, 4, 5, 6. And what we can do is plot these points. This is the number of triangles, and this is the number of dots. So when I had 0 triangles, even though this is abstract, I didn't really have 0 triangles with 2, but I could see the pattern was that. If I had 1 triangle, there were 3 dots. If I have 2 triangles, there are 4 dots. 3 triangles is 5, 4 is 6, and so on and so forth. Based on the graph, you could predict the number of things for 10. 7, 8, 9, 10 is about here. You can see up here that it would come to about 12. So the graph, the function machine, and the picture are all related, and they're an important foundation of algebra.